So we have a question in which we've been asked to find out the value of x when being given three vectors, vector A, B, and C, and given condition that vector A dot B cross C is equal to 0. So what we'll do is we'll first try to do it the pure arithmetic way, right? Where we'll use the complete expression. Okay, I mean the vector way, wherein we'll use the complete vector expression, which is B cross C, and then the cross product B cross C, and then the dot product of that vector with A. How? We have vector A, B, and C. What is vector B cross C? It is determinant of I, J, K, X component, which is -1, J component, which is 4, K component, which is 3, for the vector B, and then for vector C, the I component -8, Y component, J component -1, and the K component +3, right? Now this is basic expansion of determinants. How do we do that? I times 4 times 3 minus 3 times -1 minus J times, right? So when we use J, we neglect this column and this row. So -1 and 3 minus 3 in -8, minus 3 and -8. K would be -1 times -1 minus 4 times -8, -1 times -1 minus 4 times -8. Okay, everything looks good so far. So we have 4 times 3 is 12, minus 3 minus 1 is, sorry, 3 minus 1 is 3 into -1 is -1, minus is +3, minus 3 times -8 is -24, minus is +24, 4 times 8 is -32, minus times minus becomes plus, so this is +2, minus times -1 is 1. So we have 12 plus 3, 15, 24 minus 3. Wait, did I make a mistake here? Yeah, so it is not, it's not -21 here. Okay, so we have -21J and 32 plus 1, 33K. And therefore, we can write that vector B cross C is 15I minus 21J plus 33K. Now, what is A dot B cross C? What is the given vector A? Is -xi minus 6J minus 2K dot, sorry, it should be specified, dot 15I minus 21J plus 33K. Now, when we calculate the dot product, we multiply the respective components of two vectors, which means components of I, components of J, and K respectively. Oops, sorry for the delay. Yeah, so 15 times -x, J component -21 and -6, K component -2 and 33. So -21 into -6 is 616, 126, 33 times 2 is 66, minus into minus is plus here, we have -15x. Now, given in the question that A dot B cross C is equal to 0, right? And if A dot B cross C is equal to 0, then we can say that this expression here, so 126 minus 66x6 minus x 0, 12 minus 66. Okay, so we have -15x plus 60 is equal to 0, and therefore 15x equal to 60 and x is equal to 60 by 15, which is equal to 4. So therefore the value of x in this question is equal to 4. Now see, this is the very straightforward vector algebra method of doing it. Now, is this the question actually trying to evaluate from a JEE mains point of view? Well, of course, yes, because it is essentially asking you to find the value of x, which is which we got here as x equal to 4. Now, is that what we should be learning from this question? No. Because this product, otherwise called as a scalar triple product is a very important topic in physics, especially when it comes to higher chapters where we deal, well, to be more specific, topics which we deal with circular motion, topics such as electromagnetic induction, current, you know, those topics where we have three vectors so simultaneously in one action. So it becomes really important to understand what this product means, A dot B cross C. Okay, so in the coming two solutions, what I'll do is I will try to take you through just a glance of triple product and its variation. Okay, I hope that makes sense. Now, while we're doing this, please make sure that you write down things along with me. See, the reason why I'm repeating this time and time again is to make sure that, at least at one point of time, you will actually start following that. Okay. And I would just like to repeat that we'll just take a glance of what scalar and vector triple product is, because when a specific question comes based on the conceptual idea or the practical application or the physical implication of scalar and vector triple product, we will discuss the concepts in detail there. Since it is just a numerical one, we'll just hover to the surface of it. Okay. Okay, now let's spend some time to understand what this is.